So what I've done on this paper is basically, here's your crash course in the last 2 units. Okay, we had an entire unit on factoring, and then these 3, these were all this unit that we're in. But at a glance, here's an example for each one. So here's our task down here. It says solve each equation by choosing the best method. You must use each method only twice. Factor 2 problems, complete the square on 2, use the quadratic formula on 2, and use the square root property on 2 problems. Put the method used in the blank provided, show all work. These have both imaginary and real solutions. So what I want to show you is this little flow chart that I will also have up on the screen tomorrow when you're doing your RA, okay? So if we follow this little flow chart, it can help us land where we need to be. Let's see. All right, so I'm going to take a look at number 1, okay? Oh, actually, for this first one, the flow chart doesn't really work. Yeah. Okay, so I'm going to ignore the flow chart for this first one. Basically, before you look at any of this, I want you to look at this part right here. Is there a BX term? Okay? Because if there is no BX, then we use the square root property. You remember that? We learned that like in the beginning of the unit. Okay? So on this first one, notice there's only 2 terms. Is there a BX term? No. There's no BX term. So if there's no BX term, then we go right to here. We're going to solve using the square root property. Okay? Turn that down. Okay. So in this box, or this little blank right here, I'm going to write SRP. Okay. And then what is the square root property? The square root property, let's see, do I have my notes handy? No, it's discriminant notes. Oh, I don't. Okay. Square root property, this is where we want to get the squared term by itself. Okay? So I want to get the squared term by itself, so that would be just the x, right? The x is the only thing that's being squared, because that 4 is not included in the squared. Okay? So if I want to get the x squared by itself, first thing I would do is subtract 16. So now I have 4x squared equals 0 minus 16 is negative 16, right? Okay. All right, now if I'm using the square root property, I want to get my x squared by itself, so I have to divide by 4. So now I have x squared equals negative 16 divided by 4 is negative 4. Okay, now we're at the part where our squared term is by itself. You remember what we do when that happens? We square root, plus or minus square root. And if you still have your imaginary thing turned on Desmos, you can say, okay, what's the square root of negative 4? It's 2i. But it's plus or minus 2i, right? So x equals plus or minus 2i. And then that's just our solution. So in my solution set, I would write plus or minus 2i. Okay? Now, why did we choose the square root property for this one? Because there was no BX term. That's why we chose square root property. So when it's your job to choose one for square root property, you look which one does not have a BX, okay? Okay, so far so good?
Mm-hmm.
Okay, let's look at the next one. Okay, I'm going to bring back my flow chart. Okay, so flow chart says, is A equal to 1? Okay, so is our A value equal to 1 on this one? Yes. Okay, cool. So I'm going to follow the trail that says yes. Okay, so then the next thing says, are there factors of C that add to B? What that means is it's trying to ask me if this will factor. Okay, so are there factors of 12 that add to 7? So if we don't know that, then, well, I have to turn complex mode off. Turn that off, okay. I would have to go, all right, y equals 12 divided by x. Are there factors of 12 that add to 7? Do any of these add up to 7? What about 3 and 4? They add to 7, right? Okay, so yes, there are factors of C that add to B, so I'm going to factor it. It's basically just asking me, hey, will this factor? Okay, can't see my minimize button. Minimize, there we go. Okay, so this one will factor, so I'm going to write F here. And why am I doing that? Because there are factors of C that add to B. Of C that add to B. So I'm going to use, oh, what just happened there? That's weird. Go away. Okay. All right, and we can draw a box if we need to. If we're solving by factoring, that's how we learned how to do it, right? X squared goes here, 12 goes here, x and x. And we already looked in the table. What are the two numbers that go here? 3 and 4. So then we just figure this out. This is x and x. This is plus 3 up here. This is plus 4 here. So our factors are x plus 3 times x plus 4 equals 0. And can we do the shortcut? Because we would set x plus 3, I'm not going to do the shortcut. It's the first day back, no shortcuts. So either this factor equals 0 or this factor equals 0, right? So our two answers are -3 or -4. Okay, now why did we choose factoring? Because it would actually factor. There are factors of C, which is the number 12, that add to 7. Okay, so far so good? Okay, let's look at the next one. Number 3. All right, let me pull up this flow chart again. All right, is A equal to 1? No. So we're going to follow the trail that says no. So that now it says, is there a BX term? Yes. So I'm not going to use square root property. So I answered yes. So now I'm going to go straight to, okay, this is telling me we're going to use quadratic formula. Okay? So we're going to go to quadratic formula. Basically, if A isn't 1, and you can't factor it, we should use quadratic formula, okay? So I'm gonna put QF for quadratic formula. I'll bring my notes out here because I don't wanna write the quadratic formula yet. And why am I using quadratic formula? Because A is greater than 1 and it can't be factored. Can't be factored. So quadratic formula will work for every single one, but it's also the most work. So we only want to use it if we can't do any of the easier ones. Okay? Okay, so let's revisit quadratic formula. So I want to figure out A, B, and C. Okay, so A is 2, B is 6, C is 5, and we're just gonna plug that in to here, right? Also tomorrow for your RA, I'm not gonna like give you the quadratic formula, but you're gonna have this paper. Well, you're not gonna have this exact paper, but you're gonna have this image, and look what's on the image. The quadratic formula. So you'll just have to reference it here, okay? But I'm still not making you memorize it. Okay, x equals, so negative b, so negative 6 plus or minus square root of b squared, so b is 6, so 6 squared minus 4 times 2 times 5, all over 2 times 2. Here's my highlighter. Okay, now what part of this do I type in? The discriminant. That's the part that goes in the calculator. And you don't have to type it in like that. I mean, you can if you want to, but you can also just do this. You type in the discriminant and then you tell the calculator what to use for A, B, and C. All right, so what's my discriminant? Oh, negative 4. Okay. So x equals negative 6 plus or minus the square root of negative 4 all over, and then 2 times 2 is 4. Okay, then you have to work with your square root of your discriminant, square root of negative 4. So remember the negative, it comes out. What does it come out as? What does the negative under the square root come out as? I. Yeah. And then once I pull the I out, there's no more negative under the square root. Okay? And then you just have to work with, let me get rid of my calculator real quick. The square root of 4 is 2. So this would be 2i. So bring my work up here. X equals negative 6 plus or minus 2i all over 4. Okay. Okay, now what do you remember about real and imaginary? Can they share? No, they can't, right? Because they're in different dimensions. They can't share that 4. We have to give it to each of them. Okay, so I have to say negative 6 over 4 plus or minus 2i over 4. And then if I can simplify those fractions individually, I can. And we can, right? Negative 6 over 4, that simplifies to negative 3 over 2, plus or minus 2i over 4. Well, isn't that just 1/2? So I could put 1/2 I, or I could put 1i over 2. Doesn't matter. But that's my final answer. Okay? Okay. So far, so good? All right, let's look at number 4. Well, that one looks different. Right? Okay, so if I go to my flow chart, is A equal to 1? Well, it's not in standard form at all, right? But is there a bx term? No, no bx term. So we're going to use the square root property, okay? So if there's no bx, we use the square root property. So I'm going to put SRP, and why am I using that? There is no bx term. Okay, so square root property says isolate your squared term. This time, what's being squared? This whole thing, right? Because of the parentheses. So it is isolated. Once it's isolated, we use the square root property, right? And so I have to do plus or minus over here. So now I have x minus 3 equals plus or minus square root of 7. And if you're not sure how to, if you're not sure what to do with the square root of 7, remember we can always type it in. What's the square root of 7? Trash. Absolute garbage. So we can't write this as a whole number. Can we break it up? No. You get a 1 and you get a 7 and that's it. There's no pairs. So we just leave it like that. But we have to get x by itself. So to get x by itself, we have to add 3. And remember, we put the 3 in front of the plus or minus. So x is going to equal 3 plus and minus the square root of 7. And then that's just it, right? The only time, guys, the only time you're ever going to have nice answers is if it can be factored. You're going to notice that your factoring ones have nice, nice answers. Okay, any questions so far? So we've done one of each type except for completing the square. So let's look at this next one, number 5. Okay? So let's use our flowchart to help us figure out what to do. So, is A equal to 1? Yes. Are there factors of C that add to B? So this is basically just asking us, hey, can we factor this, right? And this is not in standard form, so I can check. Let's put this in standard form. X squared plus 4x minus 10 equals 0. Are there factors of negative 10 that add to 4? And I mean, I hope we don't have to type that in. Like, what times what makes negative 10? Negative 5 times 2. Does that add to 4? Like, no. This one won't factor. Okay? So this one, the answer to this is going to be a no. Is the bx term an even number? So is b an even number? Yeah, 4 is an even number. Okay, so then that means I'm going to use completing the square. Okay, so I want to use completing the square if it won't factor, but b is an even number. Okay, so this one, I'm going to use CTS or CS. And why am I going to do that? A equals 1. This doesn't factor. And b is an even number. A is equal to 1, but it won't factor, and b is an even number, okay? So, and look at the way the question was set up. It's even set up nicely for completing the square, right? Because the constant is on the right side. So it's even set up nicely for us. So remember our process. We're going to add something to both sides that completes the square. Okay? So let's figure out what goes here and what goes here. Well, I think the strategy that we have always been doing is draw the square. It's a square. So I know x squared goes there. I know that these two add up to 4. And I also know that this is a square, right? So if it's a square, these two numbers have to match because the squares are the same, side and top. So what will these two numbers be? 2. So if those are 2, then the side and top of our square is x plus 2 and x plus 2. So then the number that completes the square, the number that goes here,
4.
is 4. So we would add 4 to both sides. And then now we have something squared. Remember, we were writing this as the side and the top of our square is x plus 2 squared equals 10 plus 4 is 14. And then now, look, this is just like the square root property question. Now we square root, plus or minus square root. X plus 2 equals plus or minus the square root of 14. Okay, 14, is that a perfect square? It is not. Let's try to break it up. 2 times 7, no pairs, right? Those are prime, no pairs. So we leave it as the square root of 14, and we just subtract 2. So we have negative 2 plus or minus the square root of 14. Okay. Okay, how are we doing so far? All right, let's look at 6. Actually, you know what? Let's do this. Let's just decide together the best method, and then I'll give you a few minutes to try to solve those on your own, and then we'll check answers. Okay? But I'll walk you through the deciding piece, like how you choose. Okay, so number 6. Let's look. It's got to be x term. So, whoops, I didn't mean to start Microsoft Word. Nope. 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 Did not mean to do that. Flowchart, that's what I want. Okay, so is A equal to 1? Sure is. So yes, are there factors of C that add to B? And this is already in standard form, so are there factors of negative 24 that add up to negative 2? Well, let's see. Let me get rid of all this here. Y equals negative 24 divided by x. Are there any of these that add up to negative 2? Oh, 6 and negative 4, that adds up to positive 2. So what about 4 and negative 6? That adds up to negative 2, right? So that means this one will, the answer is yes, so it will factor. So I'm going to put an F here. So that one's going to factor. Okay? And I'm going to let you solve it in a minute, but let's just figure out the methods for the others, okay? Okay, so number 7, okay? It might be a good idea to rearrange these terms so it's in standard form. So if we move 10x over here, it'll be negative. So x squared, this will be minus 10x plus 30 equals 0. Okay, so now let's take a look at our, where is it? Okay. All right, so is A equal to 1? Yes. So I'm going to follow my yes. Are there factors of C that add to B? So are there factors of 30 that add to negative 10? Let's change that to 30 divided by x. Okay. Any of these add up to negative 10? Well, I need more negative factors, right? So let's do negative 4, negative 5, negative 6, negative 7, negative 8, 9. negative 10. Okay, factors of negative 30 that add up to negative 10. Whoa, here we go. What about 6 and negative 6 and negative 5? What does that add up to? Negative 11. No. Is it gonna work? Not gonna work. So the answer to that is no. Okay, so it won't factor. Is the bx term an even number? Is b an even number? Yes. Okay, so that means we're gonna complete the square on that one. That one's gonna be a completing the square question. Okay. And then, let's figure out the method for this last one. Okay? So this last one, our method, let's see, is a equal to 1? Absolutely not, right? It's 10. Is there a bx term? Yes. Boom, solve quadratic formula. So this one would be quadratic formula. Okay? All right, so this is just modeling for you, like strategies of picking the most appropriate method for each one. Okay, so I'm gonna give you about 8 minutes to take these last 3 and you solve them, okay? We've gone through the method you should use. Solve them. If you need to grab your notes, please do that, okay? And then we'll go over the answers in a minute, okay? But choosing to sit here and put your head down just lets me know who to pair up, right? I'm not gonna put somebody who's working hard with somebody who's got their head down so they inflate someone else's grade, okay? So you can expect to work with other people who are putting in just as much effort as you are. All right, stop this.